Alright, in this video I'm going to demonstrate calculating the IRR and compare and contrast it using rate to solve for an interest rate. Okay, so Uncle Olaf lent you $10,000. You paid back 4 installments of $3,000 each. He gave you 10, you paid back $12,000. What would be the annual rate on that? Okay, so that's 4 payments to pay back a $10,000 loan, completely amortized, so that's 0, and each of the payments would be $3,000. Okay, so if we use the rate function, that would be 4 payments of $3,000 in exchange for a positive $10,000 and no future value beyond that. All right, so the rate would be 7.714%. Now the IRR function calculates rate. All right, and I could have actually used IRR to do this. If I have time periods and at time 0 you receive 10,000 from Uncle Olaf. I'll center this up because I like a neat spreadsheet. And we'll call this cash flow. And then at time 1, 2, 3, and 4, you paid back $3,000. The IRR function is the equivalent of solving for rate. So equals IRR, and it's a simple function. You just cover up all the cash flows. You got to have a cash flow at time 0 and then cash flows here through period 4, but just cover all that stuff up and you come up with the exact same answer. Famous last words. A little trivia for you: sometimes there is a slight difference. That's because the people that built the algorithm to calculate IRR were not the same people who built the algorithm to solve for rate. So once in a blue moon it actually comes up with some rounding error differences. But for your purposes, the IRR and rate are always going to produce an identical answer. Okay? The thing is that in this second scenario, what if you paid it back $6,000 the first year, $3,000 the second year, $2,000 the third, and $1,000 the fourth and final year? Would that be the same? It's still $12,000, and the answer is no, it wouldn't, because he gets back half his money right away. He could lend that to somebody else, so it'll probably have a higher rate of return for Uncle Olaf. So if the cash flows were negative 6,000, 3,000, negative 2,000, and 1,000, you'd actually be paying him back at a rate of 10.75% rather than 7.71%. You pay back $12,000, but because you had to pay it back faster, it actually increased the effective interest rate on this loan. So you can use rate to calculate anything that has annuity payments where it's the exact same amount, but you can't solve for rate if their payments are uneven. That's where IRR comes in. So the IRR calculation can be used to solve for anything that has even or uneven cash flows, but only the IRR function will calculate uneven cash flows. Okay? So the IRR function is actually pretty simple way of doing these other problems. This is a shortcut, solving for rate. It's a shortcut because it's condensed. You actually have to type all this junk into a spreadsheet. But that's the beauty of Excel. Unless you're going to have something that's going to have more than, say, more than 1,048,576 entries, as long as it's less than that and you can fit it into the spreadsheet, then it's actually generally just as easy to use the IRR function to solve these problems as the rate function.